Advanced Maths, Paper 1, 2021, Question 6, Memo with Explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself. So here's some suggestions for effective revision. Don't practice questions which you firmly know that you could do. Rather, selecting questions on topics where you know that you will have difficulty. The only time you start practicing full papers is when you're trying to reduce your time taken to do the paper. If you become stuck on a question, yes, watch the video. Then it's vital you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise math is quality as opposed to quantity. It's more effective to complete fewer revision papers completely and correctly, ultimately without having to refer to help of any form, than to complete as many papers or exercises as possible. Confirmed by this Confucius saying, what I hear I forget, what I see I remember, what I do I understand. So there we have a piecewise defined function. So clearly we're going into continuity and or differentiability. So let's have a look at continuity. Requirements for f of x to be continuous at x equals a. F of a must be defined. So for example, at that point at 1, the function is not defined. Limit of f of x exists, and that means that the left limit from a minus must equal the right limit from a plus. So you can hear in this case they're not equal because the left limit we're going to 8 and the right limit we're going to 6. And the limit of f of x as x tends to a must equal f of a. So if you look here, the left limit's equal to the right limit, but in fact the limit, which is 7, is not equal to the function value, which is 6. Use mathematical notation, justify why f is discontinuous at x equals minus 2. So all we have to do is prove any one of these does not apply. Right, so x equals minus 2. Well, have a look, limit up there, limit down there. Let's do the limit. Limit of f of x as x tends to negative 2, the left limit, is 8. There we are. From the left, we're going towards the y value of 8. But from the right limit of f of x as x tends to negative 2 is 6, which is not equal to the left limit. So the limit doesn't exist. And we've justified. Limit of x as f of x as x tends to a exists is one of the requirements. Let's see why it's discontinuous at x equals 1. Well, very simply, our very first condition, f of 1 does not exist, or f of 1 is undefined. Why is it discontinuous at x equals 3? Well, f of a is defined. The limit exists because the left limit, 7, is equal to the right limit, 7. But if the limit, 7, does not equal the function value, 6. So the limit of f of x equals 7, f of 3 equals 6, and that's not equal to the limit. What is the nature of the discontinuity at minus 2? Well, have a look. It goes to there, then it jumps down to there. So exactly, it's a jump discontinuity. What is the nature of discontinuity at x equals 3? Well, it would be continuous if only we could replace that point there. So replaceable discontinuity. Explain why the limit of absolute value of x over x as x tends to 0 does not exist. Now, when you're doing this sort of thing, you always have to go back to the definition of absolute value, which is absolute value of x equals x, so it stays as it is if x is greater than or equal to 0. but negative x if x is less than 0, meaning you have to change the sign of x if x is less than 0. So we're going to break it down into two parts. We're going to do the left limit. And we're going to show that left limit, absolute value of x over x. Now, because x is positive, its absolute value of x becomes x. So it's x over x, limit of 1, which is 1. But now when we go to the right limit here, x is less than 0, so x is negative. So therefore, we have to make it negative x. So therefore, we have to change the sign of x. So therefore, absolute value of x is negative x. And that limit becomes minus 1. They're not equal. So now we have two functions, two quadratics. That for x less than 2, that for x greater than 2. And we have to determine the values of p and q to make g differentiable at x equals 2. So here are the requirements for g of x to be differentiable. G of x is continuous at x equals a. So those three steps of continuity before are expected here. Secondly, the limit of g prime of x exists, because we're talking about differentiability. That means the left limit of the derivative must equal the right limit of the derivative. And finally, the limit of the derivative must equal the derivative itself. So we're going to work with the limits. We're going to find left limit of this one and left limit of this one and put them equal to one another for one equation. We're going to find the right limit of this one and the right limit of that one and put them equal to one another to give us another equation, and solving the simultaneous equations. We're given that x is equal to 2. That's the point we're testing. So we can say we need continuity. So we're going to use continuity and then differentiability. Right, so left limit. So we can substitute left limit, which is when x, this one, for x less than 2. We're going to substitute in, and we get 5. Now we need the right limit to be equal to the left limit. So the right limit, to as x approaches 2 from the positive side, we're going to substitute 2 into there, and we end up with 4p plus 2q plus 13, and it must equal 5. And that gives us, quite simply, that equation. Let's call it number 1. So this is now using the requirements for continuity, left limit equals right limit, and that's that requirement there for differentiability. Now we're going to go on to the derivative. Left limit of the derivative of g, right? So the left limit, and we're going to substitute into this one because this is where the left is. And we're going to get x minus x plus 2, because if you differentiate that, minus x plus 2, we're going to substitute negative 2 in, and we're going to get 0. The right limit, that's when x is greater than 2, so we're going to substitute 2 into this one. So we get 4. So we're going to get 2px plus q. We're going to substitute the 2 in, and it must equal 0. And there's equation number 2. So we have equation 1, we have equation 2. And we're going to solve them simultaneously, and we get our values of p and q.